Welcome grade 7 to today's video as we step through understanding perimeter and area, the geometry side of things, of squares, rectangles, and triangles. We're going to be going over some examples of that, as well as going through some formulas, and then stepping through some of the example questions afterwards as well. So let's start off with what perimeter and area are. The perimeter is the area around, or the distance around a shape. So if you were going to be making a garden, for example, the perimeter would be the distance of the edge around the garden. Area is the entire space that's inside. So for a garden, that would be the entire space where all the dirt and all the vegetables or flowers are going to be. That's the area there. And we have different formulas to be able to figure out both perimeter and area, and they're different depending on what type of shape we're working with. Let's start off by talking about a square. So the unique part about a square is that all four sides are the same. So whatever this one is, let's say that's x, this is also going to be x, and the same thing for the other ones. We're going to use these variables to help us understand both perimeter and area. So first, for perimeter, the area around the shape, that's the distance of this plus this plus this plus this. The way to figure that out, because they're all the same size, is that it's going to be 4 times whatever one of the side lengths is. So perimeter, I'm just going to use the letter P for that, is going to be 4x, or 4 times whatever the side length of that square is, where x is the length of the side. For area, that's the distance inside here. Our formula for area is that, and I'm going to use A for that, area equals x squared, or just x times x. This times this is going to give us our area, or this length times itself. When we figure that out, then we get this entire area in between, the whole shaded area there. A rectangle is similar to a square, and here we have a rectangle. Because a rectangle might not necessarily have all the sides the same length, we kind of think of it as having a width and a length. So I have a W and an L to represent width and length for our rectangle here. And for the perimeter is the length plus a width plus another length plus another width. So in other words, it's 2 times length plus width. Whatever length plus width is, then we do that again, we have the entire area here, 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 and here. If you're ever stuck at some of these formulas, just remember that all we're doing is we're adding up width, and then another width here, and then length, and another length here to get all of the side lengths to make it all the way around. L represents our length, W represents our width. The area for a rectangle is simply length times width. So this times this. So this would, length times width would give us the entire inside area of that particular shape. So square and rectangle are pretty similar that way. Triangle is where things get a little bit different here. So let's draw a shape here. And let's represent this side as A, this one as B, this one as C. And then let's imagine we have kind of an invisible kind of H, which represents the height of the triangle here as well. So for this triangle, to figure out perimeter, just like everything else, all we're doing is adding all the side lengths together. So in this case, our perimeter equals A, side length A, plus side length B, plus side length C. There's no easier way to say that when we're figuring out the perimeter of a particular triangle. Now, when we get to grade 8, we're going to learn about some special rules when it comes to right angle triangles, but for now, this is as far as we're going to go with perimeter for a triangle here. The area is a bit tricky and a bit interesting as well. The area is the base of the triangle, which we're going to say is b, times the height. Now that seems very similar to width and length, and if we actually did base times height, we would get this kind of filled in triangle as well, or filled in rectangle, but we just want half of that, because half of that is the triangle. And so we do base times height divided by 2, or half of that. Sometimes you'll see it written this way. Sometimes you'll see it written as 1/2 times base times height. Either way, it all works. It still gives you the same answer. If you're stuck on how that works, think about a triangle like this. Let's say this is the height and this is the base, just to make it a little bit simpler here. If I were to do the same formula as my rectangle, base times height, I would actually end up with a shape that looks like this. A rectangle, length times width. But because I actually only have half of that, seeing as I only have a triangle, not this and this piece, we do base times height, and then we have to divide it by 2 because we only have half. So that allows us to get our formula for the area of a triangle. That's it in terms of our lesson for today. If you'd like to stick around, we're going to be stepping through the different example questions that the book gives us in trying to figure out some different perimeters and areas when it comes to triangles, when it comes to squares, and when it comes to rectangles. All right, for those who have stuck around, we're going to go through some of the examples here. We're going to start with example 1. And example 1 says the length and width of a rectangle are 9 centimeters and 4 centimeters. So they give us a rectangle. They say, okay, it's 9 centimeters by 4 centimeters. A square of side x centimeters has the same area of the rectangle. Okay, so we have another square here, and it has a side of x. We don't know what that is yet, but we know that whatever area this has, it's the same here. So the first bit of the question says find the area of the rectangle. Well, in this case, we have to go back to our formula. The area of a rectangle, area equals length times width. So the length is 9, the width is 4. So in this case, the area is going to be 9 centimeters times 4 centimeters. 9 times 4 is going to give us 36. Now, because we're timesing centimeters by centimeters, we actually end up with something special called centimeters squared. Whenever we're dealing with area, we're going to end up with units squared because we're multiplying a unit by another unit. So we, in other words, have 2 of them. So that's just a little bit of an interesting thing when it comes to area. When we deal with volume, volume is dealing in 3 dimensions, not just 2 dimensions. We might have centimeters times centimeters times centimeters. Then you'd end up with centimeters cubed with a little 3 here instead. Okay, so we know the area of this is 36 centimeters squared. And then we also know that our square has the same area, 36 centimeters squared. So then it asks us, find the value for x. Okay, so to figure out, I have to work backwards here. If you remember, area equals x squared. I know area. Area is 36. So 36 equals x squared. I need to figure out what number times itself, or squared, is going to give me 36. And it might take you a little bit of thinking to get there, but eventually you'll figure out that the number 6 times 6 is going to equal 36, which means that our side length of our square has to be 6 centimeters. The final question asks for the perimeter of the square, and the perimeter of the square is just side plus side plus side plus side, or x, 4 times x. And 4 times x, or 4 times 6, our perimeter equals 4x. So perimeter equals 4 times 6 centimeters, or perimeter equals 24 centimeters. Notice how for perimeter I don't put centimeters squared, and that's because I'm not multiplying centimeters by centimeters. I'm just multiplying centimeters by a number. So this represents kind of a one-dimensional line, the perimeter, area represents a two-dimensional space that has both a length and a width. And then volume later on would represent a three-dimensional space that has a length, a width, and a height to it as well. So, but that's just kind of a little bit of some side difference there. So that steps through example number 1, where we're dealing with perimeter and area of both a rectangle and a square. Example number 2 has us going with a triangle. And it gives us a triangle already. It gives us one that looks kind of a little bit like this. It also gives us some imaginary lines here. It also gives us some information here as well. It tells us that this whole span is 5, whatever that might end up being, that this is 3, and that this here is 2. It then asks us to find the area of A, B, C. Oh, sorry, this is also mentioned A, B, and C, and then we have a little D here as well. So we have to find the area of ABC. It's a triangle that we're working with. And although it's upside down, remember that our formula for a triangle is base times height. The tricky thing, though, is that we don't necessarily know this height, but we do know this height here. And so the base, the distance for the base that we're going to be working with is right here, this base here. And then the height from this base to the top of the triangle, that's what this imaginary line is 2. So base times height divided by 2. The base is going to be 3. The height is going to be 2. And then I have to put that in half. So in other words, 6 over 2 or 3. The area of this triangle is 3, and our units centimeters squared. Okay, next it asks us then to find the length of B and N. So this one gets a little bit trickier here. We have to work kind of backwards. In this case, we now know what the area of ABC is. And now we're going to use this as our base to figure out what this height is. So if we want to kind of rearrange our formula that way, we now have our area. So our area equals base times height divided by 2. Our area is 3 equals a base of 5 times height, whatever that's going to be, divided by 2. Now I need to do some fancy things with my order of operations to try to figure out what this is going to end up equaling. So to start, let's get this divided by 2 out of there. My opposite of a divided by 2, to get that to the other side, would be a multiply by 2. So I times everything by 2. 2 divided by 2, those cancel out, that equals 1. 1 times 5h is just 5h. 2 times 3 equals 6. So now we have 6 equals 5h. To get the h by itself, or the height by itself, this height right here, we need to get rid of this 5, which is now multiplied here. The opposite of a 5 times h is to divide by 5, because 5 divided by 5 is 1. 1 times h is h. So that allows that to cancel out. Whatever I do to the right side, I must do to the left side. Divide by 5, and I get 6 over 5 as my height. Or if you want to simplify it, 1 and 1 over 5 is my height. Or if you really want to simplify it, 1.2 is my height. So there you have it. We're able to work with both our perimeter and area in our squares, our rectangles, and our triangles. And if you're stuck on any of the try it questions, remember that try it 1 is just like example 1, and try it 2 is just like example 2.